Hello guys, and welcome to lesson number 1. So this will be chapter 3, and I think you already watched the intro. We will get started now with the mineral, the high detail mineral. So I set up a new Houdini scene as usual, and I will start with placing down a geometry node. So just press tab on your keyboard and type geo for geometry and place it down. I will, as usual, make it black and round, and I will call it just Geo Mineral, and I will dive inside with double click. So in this first lesson I will create, or we will create like the base geometry, and we will start pretty simply. We'll start with just a box. So I will place down a box here, and the type will not be polygon. I will choose like a polygon mesh. And now you can already this is already like a part that will influence later the shape of the overall mineral. So now you can look deeply into yourself and think how you want to be your base geometry. Will it be long? Will it be like flat and pretty wide, or will it be just a simple cube? But of course that's fully up to you. So what I will do, I will just change it a little bit. I will go for a 0.5 and 0.2, so we will get this maybe longer and a little bit thinner shape here. After that, what I want to do, I want to subdivide it. Just subdivide it a little bit, like 3 times, so we will get a little bit more geometry. And what I want to do now, I want to of course like influence the geometry, and I will do that in the first iteration with like taking geometry away, so basically Boolean geometry out, but we will do it with VDBs. So I will scatter like 4 or 5 points onto the geometry here. When you press your D key in your viewport and go to geometry, particles and point size, you can bump up your point size so it's easier to see where your points are, but I will go back to 3. The first thing what I want to do is like get a random p-scale. Of course we can do that with Vex, but I will do it with WOPs currently for the new beginners out there. So create a point WOP, or like a simple attribute WOP, that one here, place it down, and I will rename it to pscale underscore scale, because we will create 2 initial scale outputs. So I want to create like a scale output that can scale in the X, Y and Z axis, and overall pscale output. So pscale underscore scale underscore create, and we will dive inside. So what we got our point number, and with the point number we can easily create like a seed, and we will do that. So let's go to our geometry spreadsheet and let's have a look. We'll start with an add, and we will pipe that into our the PT num, so the current point number in our add, so we can use the add to create like a random seed for a random node, and we will pipe that into a random node, and the random node will now generate from an integer value, so basically a whole value, will create a float value. So for example we can pipe that out to color, and you can see the color will be randomized. But what I want to do, I want to get specifically not a float value, I want to get a 3D vector. so x, y, z. And I want to pipe that out to bind export, so we will export the value out into a value called scale. So just simple scale. And this is of course not a float value, this is like a 3D vector. And now when we copy to points, for example, you can copy the box onto there. You can already see we will get like different values on our or different stretching and height, width, because we get like the scale attribute, we export that out, and so we can influence the scale in every axis. So what I want to do now is to get like a seed, so I will place down a parameter and call that seed, and the label will be seed, whoops, not in caps, maybe seed scale v for vector, and this will be a simple integer value, and you can pump that up to maybe 500. Pipe that in here, and now you can already control your overall seed basically. Now what I want to do, now we got like this vector scale value. Now what I want to do, I want to copy the whole thing, because I also want like a p-scale, so we can get a second parameter that will control our basically overall or our uniform scale of these objects. So I want to just copy the add and the seed here, and I will rename that to seed underscore p-scale, and also here, so seed maybe p-scale. Cool, so we will generate a random value here too, and with this random value we will drive the random node. But now we need like a float output, and I want to fit the float output here, so fit range. And basically what this will do, this will fit the range between the output and the random value will always put out a value between between 0 and 1. So you can look that up here, 0 to 1 range, and we can fit that. So we got already our source min and source max on 0 to 1, and we can the destination of the value will be of course now 0 and 1, but we can influence that. So we can just go here, promote parameter, and I will rename that to minimum p-scale, and the second one to maximum p-scale, and then we can influence our range on the top level. The next thing will be a multiplier, so we can get like an overall scale, so an overall scale multiplier. Place again down a parameter, and I will call it just scale underscore mult for multiply, and again scale mult in the label, and I will pipe that out. So again, place down a bind export node, pipe that out to p-scale, and you will see our boxes will disappear because they got like initial p-scale from 0. You can already also see it in your geometry spreadsheet. And we got a few new parameters here. So we got like seed, p-scale, minimum p-scale, maximum p-scale, and scale mult. So let's pipe that up. And when we get to our copy to points, you can now see we can easily influence our boxes. So that's pretty cool. So we got now this seed here and the seed for the p-scale. and we got an overall multiplier we can use to influence our geometry. Another thing what I want to do is to place down a simple rotation function. We will place down another attribute verb, connect that, and let's rename it to create rod. So we will do it with a criterion, dive inside there. And what I want to do, I want to make a basic rotational setup. So you can also do that with a simple attribute create to show you some alternatives here. No, attribute randomize. Place that down. Attribute name will be n for the normal, so this will be, or this is I think like the quickest way inside sphere, and you got a random rotation and you can change it by the global seed. So of course that's fully up to you, but we will do that with a simple criterion function, so to get a little bit more advanced here. And what I want to do, I want to place down an add, and I want to view the points currently. The add, and what I want again the point number, and this a simple parameter again to change like the seed. This will be an integer value, the default maybe 1, and for example 500 points, the range from 0 to 500. And now we can again place down random, but now we will go from 1D integer input to 3D vector, and I want to fit that. So currently when you pipe out that one here, so bind export, just to pipe that out, here's an, oh okay, just to pipe that out quickly here, you can see all the points. Vector, 3D vector. You can see we'll again get like a value from 0 to 1, but now in a three-dimensional aspect, because we exported it out as a vector. And what I want to do basically is like to, let's just get that to seed underscore rod, and so we don't got this error here, seed rod again. And what I want to basically do, I want to fit that. So I want to fit the vector value, because, let me just show you that, scene view. When we don't fit it and we will pipe it out to the normal, for example, we will just get like a vector distribution from 0 to 1, but we also want like a vector distribution or vector direction in the negative range, and because of that negative range we will dial it down to -1, and now we also got a more randomed up values for our vector. After that, a simple criterion will do the job. We will use our random created vectors here for the axis, and we will use another parameter for our degrees, or for our basically radians for the criterions. So the criterion, if you get up here the help menu, the criterion will need an angle in radians, so we will convert degrees to radians and pipe that into the angle here. What we already can do, let's bind that out, bind export to rod for rotation, and wait, that's like a free vector, yes, free float, And what we can do, we can get this parameter here. Let's call it degrees for rot, so our rotation. Degrees for rot. And we will convert that from a float value from minus 360 to 360. We will convert that from a float value, so degrees, to radians. And now we will basically convert the degrees here to radians and pipe that into our angle. Cool, we are finished here. And now what we can do, we can rotate them on our angle. And now we can basically randomize the vector that we will rotate around, and then we can influence our rotation here. So I think that's enough for the first lesson. In the next lesson we will then deal with VDB remeshing, VDB subtraction, so basically create our first simple geometry. And with this base geometry we can then further proceed. Cool, so I will see you in the next lesson.